Hello and welcome to an example video about recursive programming in Python. In our last video, we've talked about recursive programming and I've showed you how it works and we've seen a couple of examples of it, but those examples didn't exactly show how useful recursive programming can be. The example I'm going to discuss today is the example of Tower of Hanoi, which is a fun little game that can be solved using recursive programming very easily. The game goes like this. You got three rods A, B, and C, and in rod A you have a number of disks, numbered from number 1 to number n, alright? And number 1 is the smallest disk, and number n is the biggest disk, and they're all sorted in that order. The goal is to move all of these disks from disk A to disk B one at a time. And during that process, you may never put a bigger disk on the top of a smaller disk, but the other way around is possible. Let me show you what I mean. The solve for 3 disks would go like this. First, we move disk number 1 to rod C, our target. Then we move disk number 2 to rod B, our auxiliary rod. Then we move disk number 1 from C to B. Then disk number 3 from A to C. And then, of course, disk number 1 from B to A. Then disk number 2 from B to C. And finally, disk number 1 from A to C. And that's the solve. Now, to solve this problem is possible for any number of disks, okay? N number of disks. But you could imagine the more disks you have, the more complex the game would get. Now, our goal is to create a program that gives us instructions for any number of disks and tells us what steps do we have to do to solve this game. At this point, I want to encourage you to think about a recursive approach that would solve this program. Believe me, it's going to be very easy, and if you skip to the solution directly, you're going to regret it. The easiest recursive approach for this program would go like this. First, our goal would be to move all of the top n-1 disks to our auxiliary rod, like this. And then we move our disk number n from our source to our target rod, so from A to C in this case. And then to move all of those disks that are in our auxiliary rod from the auxiliary to the target. So in this case, from B to C. And that is it. And we could code that very easily in Python. Now, if you didn't come up with the recursive approach, at this point, I want to encourage you to code this approach that I've just talked about. Now, I'm going to head over to PyCharm and implement this program. Alright, so we're back in PyCharm and I've created a new project. I'm going to solve the Hanoi Tower in one function only. And it's going to be recursive. Alright, so we're going to say def, and I'm going to call the function Hanoi Tower. And for the inputs, I'm going to give in how many disks do we have, that's n. And then I'm going to give what is my source rod, right? What is my target rod? And what is my auxiliary rod? Now, the base case for a recursive function is going to be like this. Remember, every single recursive function must have a base case. Of course, in this one, it's going to be pretty easy. If we have no disks, if n equals to 0, then just return. Do nothing and return. And in every other case, we'll go like this. We say Hanoi Tower, so we're going to move n-1 disks, all right? From our source to our auxiliary disk. Our auxiliary is going to be the target, actually. And then we move the nth disk to the target, right? So we go like this. We say, I'm going to do a print directly. We say print. Here, there you go. Move disk. And then I'm going to say, the number of that disk is going to be number n, of course, in each time. And then from rod source, and then to rod target. And then I'm going to recursively move all of the stuff that I have in an auxiliary rod to the target rod. So it goes like again, I got n-1 of those, right? From auxiliary to target, And the auxiliary in this case is going to be actually the source. I'm going to use that as the auxiliary. And believe it or not, that's it. That would solve this problem. If you don't believe me, let's go ahead and try it. Let's see. We say Hanoi Tower. And let's say for number 3, for 3 different disks. And I'm going to name my source A. And I'm going to name my target C. And my auxiliary is going to be B. Let's give it a run. And there you go. It has solved it. First, move disk 1 from rod A to rod C. That is correct. Then move 2 from A to B. Move 2 from A to B. That is correct. Move 1 from C to B. That is correct. Move 3 from A to C. Correct. 1 from B to A. That is correct. 2 from B to C. And then 1 from A to C. And that's the final answer. And it will work for any number. All right, let's see. Let's give it 10, for example. And it's pretty fast too. There you go. Those are the instructions. If you follow them, believe me, you will have a correct movement. And that is actually the shortest movement possible to solve the Hanoi Tower problem. Alright, that was it for this video, and you've seen how powerful and useful recursive programming could be. Imagine what you would have to do if you wanted to do it without any kind of recursion. It's pretty complex. If you don't believe me, go ahead and try it. I hope you enjoyed this video. Give this video a thumbs up if you did, and share it with your friends, and subscribe to the channel for more. I'll see you next time.